Alright, so for solving quadratic inequalities using algebra, the first thing that we're going to do is we're going to move all terms to one side of the inequality. Then we're going to factor, so that is not going away. We're going to remember our factoring from earlier this year. And then we're going to find something that's called critical values. This is where each factor equals 0. And then we're going to use those to create inequalities. And these are going to create intervals. So we'll do that together. We are going to make a table. And we're going to pick test values, similar to how we picked test values for our graphs. And then we're going to determine if that inequality is true or false. Then we're going to write our solution, which is an interval, for the test points that are true. Okay, so the first thing we're going to do, we're going to look at the equation for our first example here. Well, it's technically example 2 in this packet. And let's see if number 1, if we have to move terms to one side. What do you guys think? Is everything already on one side? How can you tell? What should one side always say? Yeah, one side should say 0. Okay, so if you already have the one side that says 0, you are all set. Okay, you are all good. So, we've already done step 1. Yay, now we're just going to go to the next step. Okay, so step 1. Done. Now we're going to factor. When you are factoring, you can disregard the inequality part. We're just going to look at the trinomial here. Okay, so for part A, step 1, all terms on one side. I'm just going to give that a check. Okay, step 2 is factor. Okay, so when you factor, you're factoring this part here. So there's nothing they have in common. I don't see any perfect squares, so we're just going to leave it just like this. Okay, so when you're factoring, to get x squared, you have to start with x times x. Okay, and then to fill in the rest, Ava, you're looking for two numbers that do what?
Multiply to -2 and add to -x.
Great. So multiply to -2, add to -x. It does not matter what order you put these in, but you have to multiply 1 and -2, and then you can always check that with FOIL. Okay, so when I check that with FOIL, what that means is I do 1 times x, 1x, x times -2, -2x, 1 minus 2 is -x. If this matches this, then I know that I factored it correctly. Okay, any questions for me on the factoring part? Okay. All right, and then from there, we're going to go to step 3, which is finding the critical values. So this says find the critical values where your value of each factor equals 0. So all we have to do for the critical values is take each factor and set it equal to 0. Okay, so the first factor is x plus 1. We're going to set that equal to 0. The second factor is x minus 2. We're going to set that equal to 0. And then we're going to solve. Okay, so Rashawn, if I solve here, what do I get?
X equals -1.
Good. So -1 is going to be one of our critical values. And then, Dylan, what about the second one?
X equals 2.
Yep, good. Yeah, because you add 2 to both sides. Here you subtract 1 from both sides. Okay, so the critical values, which you'll see I call these CV. Okay, the CV is -1 and 2. So what happens is this is going to be put on a number line. I'm going to show you how to do the number line, and then we're going to fill out the table, okay? So a number line is something that you guys did in Algebra 1, probably even a little bit before that. And we do want to pay attention to the sign. So the sign here, there is no equal to. What we're going to do on our number line is put our critical values on there in numerical order. So what comes first, -1 or 2? -1. And you don't have to put all the dashes on there. In fact, I'm going to try to keep this as simple as possible. And so we're always just going to put the lower number first. And then what this does is it breaks up the number line into 1, 2, 3 pieces. Okay? It breaks up the number line into 3 pieces. So we're going to talk about those 3 different pieces. Okay? The first part is here. Now I'm going to use an open circle. Do you guys know why I use an open circle? Why? Yeah, it's not equal to, so it doesn't include it. That's going to be the first interval. Okay? The second interval is going to go from here to here, and the third interval is going to go to 2 and above. So what we're going to do is we're going to label each piece, okay? And as we continue to do this multiple times, you're going to start to see some patterns. So what we're going to do is look at this interval here. So this represents all the values are -1 and below it. So we call that x is less than -1. And the reason why we use less than is because you had no equal to here. This is your first interval. So I want you to put this in the first box. X is less than -1. Again, it's less than because all the values are below it in this interval. Okay? The second interval is going to go from -1 to 2. These critical values are what splits it up. So this would be -1 is less than x, which is less than 2. And you guys think you can tell me what the last is? Yeah, x is greater than 2. Good, because it represents all the values that are 2 and larger than. Okay, so again, the critical values are what divides this into 3 different parts. So you should have 1, 2, 3 intervals, and then we're going to put them in our chart. So 1, and then here's the second one. -1 is less than x, which is less than 2. And then the third one is x is greater than 2. Okay, and then I just got those right from here. Alright, you guys ready to fill out the table together? Alright, so the second one is the test point. So the test point, what you're going to do is you're going to pick a number in the interval that's not a critical value. Okay, critical value, the critical value should produce a true statement because we know that it makes this true. So you can't pick the critical value. So this should be the number in the interval that is not a critical value. So some number in the interval that is not a critical value. Alright, let's pick some test points together. So this says x is less than -1. So what's the value that's less than -1? -2. Okay, do you have to choose -2? No, you could choose -5 if you wanted. Okay, it just has to be less than your x. Okay, this next one is telling you x is between -1 and 2. So what would be a good number for that? 0. What would be another good one? 1. Yep, either one of those would be fine. And then the last one, x is greater than 2, 3. Okay, so I'm just choosing any number in this interval here. And what I'm going to do now, the test point, this is what you plug in for x. You're going to plug it in. This says equation. It's really your inequality. Okay, so this is x squared minus x minus 2 is less than 0. And just like what we did with the test point, we're going to plug that in, and then we're going to see if it's true or false. All right, so let's do the first one together. So I have -2 squared minus -2 minus 2 is less than 0. Okay, so -2 squared is 4. This would be 4 plus 2 minus 2. And at the very least, when you're doing this on your homework, I need to see this part. Okay? So 4 is less than 0. Okay, is 4 less than 0? No. Okay, so then I'm going to put F for false. False. Okay, so let's go to the next one. Do you guys think you could plug in the 0 for this one and get the inequality? And then write if it's true or false, and then I want you to do the same thing for 3, okay? So plug it in, evaluate. Okay, I'll call on a couple of you to help me. Okay, Gwen, will you tell me what your inequality was for the second one?
I thought -2 is less than 0.
Good, and is that true or false? It is true, -2 is less than 0. Okay, and then Emmy, what'd you get for the last one? Good, and then is that true or false? Nice. Okay, now, once we have that filled out, do you guys remember what it says our solution is? Well, we're trying to find what makes the inequality what? We're trying to find what makes it true. So your solution, if you use your table, whatever interval gives you the true statement, that's going to be your solution. So when I'm writing my solution out, okay, when I'm writing my solution out, it's going to be -1 is less than x, which is less than 2. So whatever interval is true, that is going to be your solution. And then if you just wanted to check yourself to make sure that what you have is true, any value in the solution will give you a true statement. Okay, so if you wanted to check that, you could plug in, we plugged in 0. You could try plugging in 1, get you 1.5, but that would be a little bit more work. But if you plugged in 1, you'd have 1 squared minus 1, which is 0. You get -2. -2 is less than 0. Yeah, so then you know that it's correct. Okay, can you guys think of any questions for me at this point? All right, let's try the second one, and then we're actually going to do C on the back. So we're going to use this whole space. I think that just makes it a little bit nicer. Okay? So we're going to put C on the back. We'll just notate that right now. And then I want you to do part B. I want you to do step 1 and step 2. So remember, step 1, move everything to one side. Step 2, you're going to factor. So step 1, move everything to one side. Step 2, I want you to factor. And then if you can do step 3, we can look at that. Okay, Kaden G, will you tell me what you got when you moved everything over to one side? 2x squared plus x minus 1. Looks good. And then it's greater than or equal to 0. Okay, did you do the factoring? Okay, so when you're factoring, right, you want to make sure you take anything out they have in common. They don't. And then we're going to start these two parentheses. And then, Kaden, do you know how to start the two, or should we go over that together?
2x in one, x in the other.
Yep, 2x in one, x in the other. Okay, do any of you need a review on that, about why it's 2x and x? Feel good about that part? Okay, and then, Danny, what do the last two numbers have to do?
It has to add to the
Other way around. So they have to multiply to the negative 1, the last one, yeah? And then they have to add the positive 1. Okay, so really the only thing that multiplies to negative 1 is what? And? Yeah, so we just have to put the right sign in the right place, okay? So if I put negative 1 here and plus 1 here, I'm going to check it with FOIL. Again, you can check that part in your head if you want. So this is negative 1x, 2 and 1 is 2x. Negative 1 plus 2 is going to be positive x. And yep, this is positive x, this is positive x, so I did it correctly. Okay, and then Dylan, do you remember what we do for step 3?
We set both of the
Good, yep, so we're going to find the critical values. So to find the critical values, we set both of these equal to 0. So, Dylan, will you tell me what you're setting equal to 0?
2x minus 1 equals 0.
Good.
X plus 1 equals 0.
Good. Okay. How many of you have found the zeros already, the critical values? Okay, I'll give you, what do you guys think? You need 10 seconds for that? Okay, and then Seth, can you tell me what your zeros were?
1/2 and
Good. So 2x equals 1, divide each side by 2, you get x is 1/2. And sorry, what did you say the second one was?
negative 1.
Good. Subtract your 1. Okay, so these are my two critical values. When you are setting these up on the number line, and I'm going to show you how to do this so that you don't have to make this chart thing, okay? So your critical values are negative 1 and 1/2. Why did I write them like this? Why do you think I wrote the -1 first? Yeah, the number line's in numerical order, so let's put that first, okay? And then we'll do step 4 together. This is the making the table. I'm going to show you how to do it without having to like do a bunch of stuff on your homework, okay? So here you have -1 and you have 1/2. So numerical order. Now we're going to set up the intervals. The intervals are just going to go at the top, okay? To do the intervals, you just have to look at this sign. So see how the sign does have an equal to? Has the equal to? So now we just have to put the equal to in our intervals here, okay? So the first interval goes from -1 all the way down the number line, okay? It goes to -infinity. So that's going to be x is less than or equal to -1. So this part of the number line represents all the values that are less than -1. Questions for me about that one? Okay, the next interval, so remember, this is how they're split up. This is the split, okay? This is going to go from -1 until my other critical value, which is 1/2. So, to write this as an interval, I would say that this value is between -1 and 1/2. So, -1 is less than or equal to x. And that is less than or equal to 1/2. You guys feel like you got the last interval? Okay. Brianna, what's my last interval going to be? Good. Okay, so this guy here is greater than or equal to 1/2. Now, as we continue to do this, you're going to see this pattern. This is always going to be less than or less than equal to. This will be a less than and a less than, or equal, less than equal to, less than equal to. This is always going to be a greater than or greater than equal to. Okay, so I got my intervals. Now what do I got to do? Yeah? And so I'm going to make the chart here. So in my chart, I did the intervals, then I picked my test point. So let's write the test point here so I don't have to like construct the table. You can construct the table if you want to. I just know we're trying to like write things down as quickly as possible sometimes, so this might help you. So all I have to do for the test point is pick a value that's less than or equal to -1. What do you guys think? -2 works, good. Okay, this is -1 is less than or equal to x, which is less than or equal to 1/2. So it has to be in between those. So between -1 and 1/2. What do you think? 0. Excellent choice. All right, and then the last one, x is greater than 1/2. Yeah, let's just do 1. Okay, and then when you're doing the test point, okay, this is your value of x. Where do you plug it in? What are you plugging it into?
In the equation that is equal to 0, or like
Yes.
equal to, but
Yeah, the inequality. Okay, so I'm going to put the original inequality, and really you can either do this one in the problem or you can do this one from step 1. Doesn't matter. Really doesn't. You should get the same thing. So 2x squared plus x minus 1 is greater than or equal to 0. That's fine. Okay? So when I plug that in, I'm going to show my work here. I have 2 times -2 squared plus -2 minus 1 is greater than or equal to 0. I'm going to split it like that. and then really, once you do this, all I'm looking for is that you have your inequality here. So negative 2 squared is 4, 4 times 2 is 8, so this is 8 minus 2 minus 1, which is going to be 5. So I end up with 5 is greater than or equal to 0. Is that true or false? True. Okay. All right, so I want you to do the plug-in for 0 and 1. Okay? And then think about how you're going to write your final answer. We'll go over that together. So you're saying true or false. Yeah, I'm going to write out our solution. And then if you feel like you got that correct, go ahead and start C on the back. That's fine. Right, now with this one, how many statements ended up being true? Yeah, there were 2 of them that were true. So we do have to write that in a special way, okay? And like I said, I'm fine if you put the final inequality here, but it might help for you, it might help you to write down what you're plugging in just to make sure you don't make any small mistakes, because this part is going to be 0, but you still have the negative 1. Okay, so negative 1 is greater than or equal to 0. Is that true or false? False. So if it's false, put the line through it. You don't want that there. You don't want to leave it if it's not true. You want the slash. Okay? And then 2 times 1 squared plus 1 minus 1 is greater than or equal to 0. Is going to give you 2 is greater than or equal to 0, and then that is true. So I don't want you to just focus on whether you got true or false. We have to make sure you have the right statement. Okay, so do you have 5 is greater than or equal to 0? Negative 1 is not greater than or equal to 0. 2 is greater than or equal to 0. Okay, so we got to make sure we get that part right as well. So once you find the ones that are true, if this is true and this is true, then these are going to be the true statements. And we have to connect these with an or, because can x be a value that's less than negative 1 but greater than 1/2 at the same time? No, there's no number that does both. So your solution is x is less than or equal to negative 1, or x is greater than or equal to 1/2. Okay, so x is less than or equal to negative 1, or x is greater than or equal to 1/2. Okay, and then I want you to start part C on the back. So C, the equation is right there. So you put that on the back for me. Alright, now this one, you do have a negative in front. Do you guys remember one of our strategies? If you have a negative? Yeah, I think that part is the easiest. I know some people don't mind working with the negative, so you don't have to, but I think it makes the factoring a little bit easier. Okay, so Aurora, what was the first step that you took for this?
Change the -1.
Okay. Good. Okay, so we're going to add 1 to this side. So you have negative 2x squared plus 3x plus 5. Good. Is greater than or equal to 0. What I don't want you to do is I don't want you to divide by -1 because you have to factor. When you divide by -1, that actually is going to alter the inequality. Do you guys remember what the rule is? You divide by a negative, what happens? It flips the sign. Okay, so when you're factoring, okay, you can factor out the negative. And think about what that does. You're really just factoring out a -1. So if you divide everything by -1, it changes signs. So this becomes 2x squared. This becomes negative 3x. This becomes negative 5. And again, if you factored this with the negative in, that's fine. If you did like negative 2x and x or 2x and negative x, if you got it to FOIL that way, I'm perfectly fine with that. But I think it's a lot simpler to factor when you have a positive number here. And we do think of the negative as a GCF. Now to quick check, I just do negative times this. Yep, negative times a negative is a positive. Negative times a negative is a positive. Yep. So when I factor, I take the negative down, and then this is just like the one before. So to get 2x squared, I have to start with 2x and x. The only way to get to -5 is to have a -5 and a +1, or a -1 and a +5. Okay, so I'll give you a second to factor that. Do you guys need a minute to factor it? And then I want you to find your critical values. Lizzie, what did you get this to factor to?
I was a little confused on that one, so I did the other one.
Oh, okay, with the negative. Okay, yep, that's fine. Julianne, did you factor this stuff?
No.
Okay, are we guessing and checking some things? Okay, what do you want to plug in? What do you want to try?
Well, for me, I just did nothing inside.
Okay.
So I did.
Oh, okay, so you did like the -2 and stuff? Okay. So really what we're playing around with here is if I have -5, like I can try -5 and +1. So I'm gonna see if that matches up here. And then if I have -5x times 2x, that's gonna be -3x. And so if these match here, I know that I'm good. Okay, so if you guys factored with the negative in, you could have, Lizzie, you want to tell me what you got? Or were you still playing around with it?
Well, I was still doing it. I wrote 3 instead of 5, so that's why I was.
Oh, okay. So like, are some of you starting it like this? Ashley, I think you started it like this, right? The -2x and x?
Yeah, I changed it.
Oh, okay. You guys can do it this way too. It's just, you'd need like +5 and then +1 to get 5x minus 2x, that would be 3x, and then you would just make sure that it foils back to this. You could do it like that. Okay? But I did mine to the middle one. And then when you do your critical values now, all you're doing is this negative, if it's in front, if you set that equal to 0, do you have anything to solve for? Is there an x? Nope, so you don't even have to worry about that. And then to find the critical value, you have 2x minus 5 equals 0. And then x plus 1 equals 0. So those are going to be your critical values. Okay, so to find your critical values, all you have to do for your critical values is find where x is going to be 0 for each factor. Okay? All right, and then Maya, can you tell me what you got for your critical values when you're ready?
-1 and 5/2.
Good. All right, so now we're going to put them on the number line. And when I'm putting them on the number line, Jack, what do I have to remember to do?
That would be to shade like the bubbles in.
Oh yeah, you can do the bubbles, but how do I know like which one goes first?
Well, the -1 goes first because it's from the numerical order.
Exactly. That's all it is numerical order, right? So the -1 goes first. Great. Okay, and now we're gonna write our intervals. I'm gonna give you a minute to see if you can write those. Okay. How many intervals should you have? 3. Okay, so 3 intervals. After the intervals, you're going to find the what? Yeah. Okay, so Cooper, can you tell me what your first interval is here? And with this one, you are going to want an equal to, and that is only because the original has the equal to. So if it has the equal to, we're going to include it there, but that's great. Okay, and then Brianna, what's my second interval?
-1 is less than or equal to x,
Yeah,
which is less than or equal to 5.
good. And then Sam, what's my last one? No, you're right, X is. So X is greater than or equal to 5/2. And this last one will always be greater than or equal to. So, and when I learned this, did you guys learn like the alligator likes to eat the bigger number? Like if it's whatever it's eating is the greater than. I still like that. All right, so now we're going to do some test points. So the test points just have to be in your interval, okay? So Dana, I'm going to have you do this with me to pick the test points. Okay, so see this here, it says x is less than or equal to -1. That just means you have to pick a value besides -1 that is less than or equal to it. So what's a value that's less than -1? There you go. Okay, so we're going to plug that in. Okay, and then Dane, for this one, this is saying x is between -1 and 5/2. So it's like a value that's between -1 and 2.5. So what do you want? Okay. And it's okay if you guys chose 0. Okay, so any one of those are fine. And then what about this one? So x is greater than 2.5. Sounds great. Does that part make sense? how we're picking those, so you can choose. Okay? And then we have to plug them in, right? Where are we plugging them into? Yep, into, and you can either use the original equation or you can use the equation or the inequality, okay, that you got in step 1. So I like to use this one where I'm comparing it to 0. It doesn't matter to me, you just have to tell me what you're doing, okay? So it doesn't matter if you use this one or the original, I just need to know what's happening. So for -2, if I plug this in, it's -2 squared plus 3 times -2 plus 5, greater than or equal to 0. So I'm just going to find that, see what happens. I do the same thing with 2, right? So -2 squared plus 3 times 2 plus 5. Okay, and then this one is, we chose 3, so -2, 3 squared plus 3 times 3 plus 5 greater than or equal to 0. And then we're just going to evaluate, right? -2 squared is 4. -2 times 4 is -8. So this is -8 minus 6 plus 5. -14 plus 5 is -9. And then you just have to tell me if that's true or false. Okay, so Dane, is -9 greater than or equal to 0? No. So this is what we do. We just put a slash through it. We write false. And then we move on to the next one. Okay? Alright, and I'm actually going to, I know that, did some of you choose 0 for this one? Okay, I'm going to show you that it doesn't matter, okay? So this is -2 times 4 plus 6 plus 5 is greater than or equal to 0. So this is -8 plus 11 is greater than or equal to 0. So if you chose 2, what you should get is 3 is greater than or equal to 0. And guess what? That's true. Or, and the only reason I know that some of you chose 0 is because we've been working with 0 a lot. So if you chose 0 as your test point, then you did -2, 0 squared plus 3 times 0 plus 5 is greater than or equal to 0. Then you would have got 5 is greater than or equal to 0. Is that true or false? True. So see, no matter what you do, this is true. Any Spandau Ballet fans in here? They have a song called True. Do you know what I'm talking about, Aiden? Oh. I know this much is true. You guys have had to see The Wedding Singer, right? What? New homework assignment. Watch The Wedding Singer. Now we can talk about how good it is. Okay, is -4 greater than or equal to 0? No, so don't let it stand. You put a slash in it. How dare you try to be true when you are false. And then your final answer is going to be whichever interval gives you the true statement. So your solution is going to be -1 is less than or equal to x, which is less than or equal to 5/2. Alright, I'm going to give you some directions, so pay attention to these, okay? So I'm going to show you the calendar so you know what is due when.